satisfies our system, right? And then it says, okay, the other ones are still pretty much equivalent in the liquid phase, but in the vapor phase, really not so much. And that's a consequence of this feed, right? So that feed could be anything, right? So if we change it, if we said that this one is only 0.1, 0.3, let's make it 0.2, 0.3, 0.4, then we're gonna have to solve this again. As it is, it's solved. No, again, the feed doesn't necessarily matter, right? It's this that matters, the mixture composition. But I guess what we have to do is we have to reset it, right? So the feed then, right? So these XIs don't necessarily work with that feed, right? So it all depends on where we start, right? So I can't have more than I started with. Right? So what we can do is actually take these out, solve it again. Well, that doesn't make a lot of sense, right? Because we can't create more than we had in the first place. So at the first pass, we kind of have to rethink, right? So that what we just did was fine, right? If I start with 0.25, 0.25, 0.25, 0.25, this works, right? But it's not the full example we did in class, right? So again, this example does work. I mean, it does set V and L, right? We haven't solved for psi. What we've essentially done in this case is really get a set of K values that work. And what is going on? Is that projector? Okay. So what we got really then was a set of K values here, if nothing else, right? Because we already set V and L. So maybe what we have to do then is put another layer on this, right? So again, what we just did gave me some set of K values that are pretty reasonable for this system. Yes, it does give me X's and Y's, but what happens then if we set different initial guesses, right? So looking at this, what if I made this 0.1, 0.2, 0.3, 0.4? I'm gonna copy these K values from there, because I wanna see what happens if we start with different initial guesses. Right, so if we run this again, but we started with a different guess for xi. Right, you can see we got slightly different answers. The vapor, not so much, but the liquid, somewhat. Right? So really then, this depends a bit on where our guesses came from. Right? So again, when I started them all equal, I got one set of answers. When I started then from a different value, I got a slightly different set of answers, right? So you may have missed that, but let's look at that, right? So these are our K values, which are more or less constant, right? So actually what we did was find a good way to solve K values. Right? So the solution actually gives us a set of K values that's pretty reliable, but the liquid mole fractions and the vapor mole fractions actually depends somewhat on the initial guess. So maybe this first approach is really good for getting us K values for this problem. Now let's go back and look at, I'm trying to give us the decimal points, right? Yeah.
Our K values are actually the same as they were before we actually solved it.
They are. Yeah, yeah, that's what I'm saying. Yeah, so the K values are really the reliable thing that we got here.